welcome to episode 6 of Udacity Talks, our live series event where we discuss topics with powerful thinkers in Silicon Valley on the areas of education, careers, and the hottest technologies, and take your questions. I'm Shanaz Davar, the Chief Marketing Officer at Udacity. Today we're doing something a little different. We're flipping the script where Sebastian, who generally is the host, is going to be sitting in the guest chair. And the reason being, Udacity just announced its self-driving car Nanodegree earlier this week. And who better to talk to you about self-driving cars and answer hundreds of your questions than Sebastian, who is pretty much regarded as the inventor or the godfather of the self-driving car. Sebastian, it's been quite a big week for you.
Yes, it
You
is.
launched a Nanodegree. You already have over 4,000 applications filled out for this program. How are you feeling?
It's crazy. We expected a few hundred, and we have a few thousand now. It's going so fast. It's amazing.
Why do you think this is happening?
I think there's something in the air about self-driving cars. 5 years ago, when I talked to people, they smiled at me when I said self-driving car. The same way when I say flying car today, people smile at me. And now it's become so real with like Uber and others in this space that lots of young people just want to work on self-driving cars and help them shape up. So what we do at Udacity is we empower students to become self-driving car engineers.
We've had a ton of questions when we put this news out there, and the questions coming from Canada, from the United States, from India and China. So I'm just going to dive into them and let's see how far we can go in 30 minutes.
Absolutely.
So from Fido, what originally gave you the idea of creating a self-driving car?
I've been a roboticist in my life, an artificial intelligence researcher as an academic discipline. And I cared about that because I felt it would be great to understand intelligence. And what better way to understand intelligence than just building it yourself? Obviously, I had car episodes in my life, some sad. I lost a good friend in high school. But I really got engaged when DARPA launched a competition called DARPA Grand Challenge in 2003. I was on my way from Carnegie Mellon, moving over to Stanford University, when this competition came along. And I decided, why not? Why not just give it a try? The very first of those competition, the best driving car made about 7 miles out of 140. And I thought we could do better than 7 miles.
Did you do another challenge after that?
Yeah, so the challenge was repeated. It was repeated 2 years later, 2005. And we won it. We had about 196 different teams competing for this prize. And my team was the lucky one that won it.
That's great. So here's another question from John Eric. What is your projected timeline for the development and proliferation of these self-driving cars? And what do you believe will be the major obstacles?
So I'd say at this point it's fair to say that the technology is basically there. Not every player has the full technology, but I've worked for many years at Google, and I believe Google's technology is on par or better than human driving. So it's really more of a question of getting this out in the field, developing the right business models, having the right legal framework that we can actually do this, and getting customers involved and building up the network and the brand and trust of people in this new technology. And that's going to happen in the next maybe 5 years or so.
Wow.
There's a big race going on, obviously. There's multiple business models. There's transportation as a service, where cars come to you like a taxi. There's owner-operated cars. There's aftermarket businesses. There's specialized things like truck driving that auto pursues. So we will have to see which firm will be the fastest.
What do you make of the Uber news this week?
It's great to see Uber in that game. And Uber has for a long time, Travis for a long time has told me that he's really afraid that a self-driving car could destroy his existing business. And he's doing the right thing. He tries to really get into that business, understand it. He's hired some phenomenal people. He just acquired a company called Otto, which is my former partner and student, Anthony Nowalowski.
And
So-
someone you're partnering with on the
Yeah.
Nanodegree.
Yes, and someone we're partnering with at Nanodegree, as Udacity.
That's great. So now we have a question from Z. Is it better to build a self-driving car from zero or to integrate self-driving technology into current cars on the road, a little bit like Tesla is doing, and why?
So from zero, I would not build a physical new car. If you really want to make the car smart, what you really want to do is you want to replace the driver, not the car. So you really have to worry about human eyes, aka cameras, human hands, aka actuators inside the car. And it's really an artificial intelligence endeavor. I think integrating the existing cars is a good idea if you want to do it, because you just buy a car, you hack it a little bit, and then you can drive it automatically. In fact, at Udacity, we did this together with a company called Autonomous Stuff. We got a car, we bought that car is ready for what's called drive-by-wire. So we have a little remote like a video game. We can go forward and backward and left and right and so on, and turn the turn signals. And students that take our new Nanodegree in self-driving cars will be afforded the possibility to actually run their software on our car in real traffic. So you could be sitting in Sweden, you could be sitting in Bangladesh, and all of a sudden your software would drive a car in America.
Wow. So you kind of went to the next question, for which we've got about 50 of the same questions, is what is the self-driving car Nanodegree designed for, and will I get a job after?
Yeah, so we worked with companies, the ones we listed publicly so far as Mercedes, NVIDIA, Didi in China, and Otto, the startup company. And we basically went to them and said, hey, guys, we want to start a curriculum where we raise amazing people. What do these people need to know? And then these companies have very specific lists of things that they're after. Could be localization, could be deep learning, it could be real-time control. So we write all these things down, and then we ask the companies what type of project would prove proficiency. And the companies have, again, have a very strong opinion. Say, look, if you can do the following type of a situation, we're going to hire the person. So that's what basically our curriculum has become. It's become a list of things, of skills and knowledge that students ought to know to be proficient in self-driving cars. And our hiring partners that we announced with yesterday, or 2 days ago, they actually signed a deal and said, look, we're going to hire those people. It doesn't mean there's no interview. Of course, there's an interview, there's a decision to be made. But they are very willing to hire graduates from our program. I should go further. I mean, the industry is large. It's not just here in Silicon Valley. It's in Detroit. It's in Germany, in Stuttgart, and many other places. So there's many, many places around the world where people are gearing up. It's not just the car industry. It's the tech industry. Intel, NVIDIA have entered the game. Baidu. So many different companies you wouldn't think of as car companies. So all of those are desperate to hire talent. I think we can easily place 10,000 people or more.
In what time frame, 10,000 people?
If you had 10,000 well-trained people right now, I bet within 3 or 4 months you would find jobs for pretty much all of them.
That's pretty impressive.
Yeah, that's our goal, to make our students happy.
That's great. So we have another question from Shreyams in India, and I hope I'm pronouncing your name right. Do you think there could be self-driving cars in India where the roads are not linear, they're really curvy, and where the traffic flow is not linear?
So I've spent time in India in traffic, and I've tried to understand Indian traffic rules. And I walked away thinking it's different from America, and I've seen instances where it seemed that the bigger vehicle had the right of way over the smaller vehicle. So the buses and the trucks first, and then the cars, and then the Rishkas, all the way to the bicyclists. There are rules. And what the self-driving car is really good at is precision. So the self-driving car has an unbelievably high precision in understanding where it goes, where other cars go, and where they can squeeze through. I have not in my time at Google, and to my knowledge Google has not launched anything in India today, and it would take a substantial revision of the software to deal with that kind of traffic. But I see no reason why not, to be honest.
So you think that self-driving cars, if they see a cow coming out of the blue, they will be able to detect it and be able to tell?
Yeah, I mean, right now, if you see a child coming out of the blue running after a ball, the car will stop for the child. Cows are larger, and it's actually easier to find, and they move slower for most parts. So yes, we believe it's doable. Again, this is something we have to show, right? We have to really build. But I see no principal reason why a place like India or Pakistan or Egypt should be different than a place like the United States.
That's great. So one of the questions that comes from Jordan is, how do you kind of deal with the ethical issues of a self-driving car where you displace so many people out of jobs because now the car is going to drive themselves? What happens to those people?
I think, there's a general question about progress. We've made enormous progress in the last 150, 200, 300 years in technology and automation and so on. And in doing so, we've freed people of certain types of work and empowered them to take different types of work. Just to remind us, about 300 years ago, we would all have worked in the fields. And then we would go and plow every day or milk cows every day over and over again. And the defining attitude of humans was our physical strength and our agility. It wasn't our mind. We weren't really trained to be thinkers. We were trained to be doers physically. And yes, it's true that the agricultural revolution and followed by the industrial revolution displaced a lot of work. I think the outcome is actually very desirable if you look at it, because now we have so much more interesting jobs. And we have so much more interesting lives because of it. We don't have to do the same remedial physical thing over and over again to barely feed our family. We have plenty of food in the world, and we can become playwrights, we become actors, we can become television anchors, we become engineers, we can become pilots. All these things didn't exist 200 years ago. So I think what's going to happen here is the same thing. repetitive work, like, I don't know, driving your taxi. At some point, I think we're going to have amazing people who otherwise would have been taxi drivers that become inventors, that become creators. And we empower them to do this. And part of Udacity's mission, of course, is to teach those wonderful people all these wonderful skills.
That's great. Sometimes I hear you often talk about self-driving cars not just affecting transportation, but transforming a ton of industries. And people have never actually understood that or tried to figure out what it is. Could you share a little bit of your thoughts over there?
Yeah, so, I mean, first of all, the automotive industry is a huge industry, specifically if you count all the suppliers that supply into that industry. So if transportation as a service becomes reality, like the Uber that comes to you without a person inside, we probably need a quarter of the cars we have today on the streets. That means it'll be bad days for manufacturers, to be quite frank. But other companies, say insurances, insurances in the United States view car insurance as being sold to a car owner as one of the most profitable instruments. If insurances now have to insure providers, entire companies, they will be able to negotiate completely different rates. Possibly companies are self-insured, like some of the rental car companies. Insurance for cars will go away. But other things like parking, for example, right? So right now, if you build an office building, you have to supply parking. In the future, you might not have to, which means our offices will be closer together and land will be utilized much, much better. Restaurants, you might be able to just drop myself off and the car goes away. I would be concerned if I was a parking garage operator. That might not last that long, that job.
Right.
But the nice thing is I'm looking forward to the day when I come to San Francisco and the streets are free and there are no parked cars. Because right now it's a nightmare. Most big cities are full of parked cars. What a waste.
It's true. I think somebody had said, in fact, you had that 60% of space in Los Angeles is devoted to parking garages. Is that correct?
Cars in general, so roads, driveways, and garages. It's more than half. It's 60%
Right.
of Los Angeles landmass. And not all of it will go away. I mean, the streets will stay. But just imagine you don't need a garage anymore.
What do you think happens to people? What do they do in the cars? Do you think about that?
Well, we in America, we lose about 52 minutes every day, every working day in car-based traffic on average. That's our commute. It's a half an hour commute in, half hour commute out is about the mean. So that's time that's lost. That's a lot of time in life. If you work it out over a lifetime, it's actually really a lot of time. Right? It's like a 24th of your total time.
Right.
So if you live 24 years, you lose 1 year.
Right.
So if you live 75 years, you lost 3 years in cars. Now, I want that time back. I mean, I'd sleep, I do homework, I watch a movie, whatever, I text safely and email, but I don't want to be the monkey in traffic, congested traffic, doing the same steering and gas over and over again and having to pay attention.
Yeah. Here's a question from Phil. How big a role do you think high-accuracy GPS receivers will play in the autonomous car industry?
They already play an important role. So we have a GPS receiver on pretty much every self-driving car. And while they tend not to use differential GPS, because it's hard to have a ground station, they tend to use something like WAS, Wide Area Network, to really get foot, 2, 3, 4 feet errors. And what Google did on top of it, Google acquired a map of the street. And after the coarse localization provided by GPS, it does a fine-grained additional localization just by comparing the current sensor scan with the previously recorded map. And those technologies are very important. Tesla doesn't do it. Tesla doesn't have a map. And you can see when you drive a Tesla that if there's a turn coming up, Tesla often doesn't know a turn is coming up until it's very late and might, for example, not slow down for a turn. But with precision GPS, you can actually really give these cars an elephant memory and build a map of every single street. And that allows you to do a lot of safe stuff in advance. They can slow down for turns, you know where the turn looks like. If the turn is not visible, you can still start turning and so on.
Interesting. Kind of similar, Annie has a question. As this amazing technology is being developed, there is still debate about using self-driving cars, and when an accident happens, who holds responsibility for that?
I think there is precedent for this, and there's a fairly clear legislative situation for liability. If the cause of the accident is with the manufacturer, I would posit that the manufacturer should have liability. If the cause is with the operator, then the operator should have liability. And sometimes it's a little bit mixed. And I'm very much looking forward to the assessment that will come out with the most recent Tesla accident, where this is the first time that the law is actually being tested. The nice thing about self-driving cars is that they record a lot of data. So in our Google car, we would get in minute detail every motion of everything around it. And it makes it really easy to determine whose fault it was in the end. Much easier than conventionally, where you might have an eyewitness or not, but that's all you have. So I see a time where trial lawyers will have less work because the cars will just have a very clear-cut decision who's at fault.
So that industry gets disrupted too, the law industry?
I think, yeah, anybody having to do with collision, like collision repair, trauma surgeons, trial lawyers, if we do our job well, then we don't need them anymore, to be honest, at least not for cars.
It's either a scary world or a fascinating world.
It's a phenomenal world. I mean, what is good about people, young people, old people having an accident, coming into a hospital and having surgery? I mean, there's nothing that I could describe as good. What is good about when people have to argue who's at fault afterwards and spend lots of money on lawyers? I mean, I love lawyers, but is this a great use of our societal potential? No, I don't think so. So for me, anything related to accidents has a negative rap.
This is from Awel. I'm a software engineer working in Belgium. I just got a PhD in wireless sensor networks. I'm wondering if I need knowledge about mechanical engineering to be able to craft a self-driving car.
The answer is no. I mean, if you have it, it's good. If you have a friend with mechanical skills, it's good. But self-driving cars is basically a topic of artificial intelligence. It's really a software issue. The interface of the car is relatively easy to build. All you do is you snip a few wires and you give signals into the brake and signals into the gas and signals into the steering. And from that point on, it's all about intelligence. It's all about perception, bringing in camera images, interpretation of what's in the images, and then turning those into control decisions. So my Google team, when I started it, we hired, I think, in the first year and a half, 12 engineers. None of them were hardware engineers.
Was one of them Anthony from Auto?
Anthony was the only person who was halfway hardware engineers, correct.
Good. And in relation to that question, do you think I need to have taken specific courses before applying for your Udacity self-driving car Nanodegree?
So right now it's hard to get in. We have about 4,000 applications at this point for 250 seats. We're going to extend the number of seats. What we said publicly is that there's a prerequisite. You have to be able to code, preferably in something like Python or C++. And you have to have some good mathematical knowledge, algebra and statistics in particular. And that should be able to get you in, modal the fact that we have more applications than we have slots right now.
What happens to the people that don't get in? What are you going to recommend to them?
We open it later and let more students in. We will grow this program to thousands of students at a time. There's no question. We're running it small right now because it's the very first iteration and we just want to make sure it's great. And we don't want to have too many people being confused when something is unclear. But this will grow, yeah.
That's great. What will successful students of a self-driving car Nanodegree look like in 10 years is one of the questions.
I hope that successful students will come back to us in 10 years. I hope they're going to get a wonderful job at Mercedes or Google or any of these companies, or build their own startup company. And after helping to advance the world and make this technology mainstream, they might say, now I want to work on drones or on virtual reality or something else. And I hope they're going to come back to us and remember that they got our education from us.
That's great. So there's a question that kind of comes up, is self-driving cars only limited to the large companies because we only hear about Google and Ford and Uber, or can you have a startup in this area?
You can absolutely have a startup. Otto is a good example. Zoox is another example. Former PhD student of mine, Jesse Levinson, co-founded Zoox. It's a service company. And there's many, many small companies. Sometimes the progress in small companies is actually much faster than in large companies. So if you're curious, come out to Silicon Valley, visit some of the existing companies, and start your own.
That's great. One of the questions comes up is, I'm not in Silicon Valley. If I were to get a self-driving car Nanodegree, what would I be able to do in my country?
Depends on what country you live in. I mean, North Korea is one thing, but many, many countries have automotive industries and build cars or car components. And even, I mean, I've talked recently to the King of Jordan about self-driving cars. Even countries that might not have their own industry still have a need for engineers because they would wish to deploy this kind of technology and become a technology country. Further, I would say the skills that you will learn in this Nanodegree are broader than just self-driving cars. They have to do with estimation, perception, artificial intelligence, controls. So any other physical system, like a robotic system, is very well covered under the skill set. So the skill set is very broad, and I'd be shocked if you couldn't find a good job with that.
So you walked into this one, but since you met with the King of Jordan, what did he say to you?
We had a nice, beautiful conversation about his country and about the situation in the Middle East. We had a few business conversations. I have myself a very strong interest in bringing Udacity education to the Middle East. We already have a refugee program in Germany for Syrian refugees together with the BMW Foundation. We Googled, we have about 5 different classrooms in Egypt. So one of my goals right now is to see can we bring more education to the Middle East, because it's one of these regions where I believe there's amazingly aspiring people there, and they're really so disadvantaged when it comes to education.
Could they be able to take the self-driving car Nanodegree?
Yeah, I mean, subject to applicable laws and subject to internet availability, yes.
Another question from a student. What is the greatest challenge in achieving a self-driving car? If you were to guess, where will the solutions come from?
So the biggest challenge is this mean little 1% of cases. So making it drive 99% autonomously is easy. The 1% is hard because this is stuff that's really rare. And of this last 1%, the very first 99% is still easy. But then this last 1% of 1% is hard. And the variety of things you encounter are enormous. At some point, I remember we had a plastic bag blow over across the highway, and our car went into deceleration because we thought it was an obstacle. We hadn't taught it yet that plastic bags can fly in the air across the highway of the size, if they were on the ground, it could be a massive rock.
Oh my gosh, right.
So we had so many of those situations. We had strollers go crazy in streets. We had deer jump in front of us. Things that are extremely hard to anticipate. And that's where driving comes in. That's the reason why we drive every day. We get a lot of data, and then we can categorize the data and improve the software.
Was all of this happening when you were at Google?
Yeah, yeah.
What was the biggest surprise that came for you when you were doing the self-driving car project at Google?
Well, the biggest surprise was that we could do it, honestly. I remember sitting with Larry Page and Sergey Brin brainstorming what we should do, and they just said, look, Sebastian, why don't you just drive 1,000 miles in California, all hands off?
Oh my gosh.
And put this in, and not just any miles. They said, we're going to find you miles that are really hard, like downtown San Francisco and Bay Bridge and to and back from Lake Tahoe. And we took a coastal road from San Francisco to Los Angeles, like a nice little mountain road, not a highway. And my take at the time was, that can't be done. We had just done the Java Grand Challenge. We'd driven through an empty desert with nothing, and the cars would be careening along. And Larry pushed me hard and said, look, Sebastian, explain to me why it can't be done. And I ran out of arguments. I almost like yelled at him and said, I'm the professor, I can know it, God damn it. Which of course is admitting that you don't know it. And then I said, okay, why not? Let's just give it a try. And I learned an important lesson. The lesson is if you don't aim high, you don't shoot high. You really got to try these things. Almost every expert who says it can't be done is wrong in almost every field.
That's amazing. What was the one disappointing thing out of the whole project?
I mean, when you ask disappointing, I wish I had seen it through all the way to launch. I wish it would be available today for public consumption. I mean, Google has done made enormous progress in its technology, and I think, as I believe, is now more reliable than people. And we're still longing for the step when I can actually use it as a normal citizen every day.
After completing a Udacity self-driving car Nanodegree, do you think someone could be able to make an autonomous car just with easily attainable off-the-shelf parts, almost like Lego?
Yes, absolutely yes. But it requires a certain skill set, which is what we don't teach is how to snip wires in your Toyota Prius to actuate steering wheel and brakes and so on. So you have to build your interface to your car. We're not teaching this for safety reasons. But once you have control over those components, you should basically know everything you need to know to build a self-driving car. How
long do you think it would take in the hypothetical world to just build a self-driving car after getting this degree?
Well, funny you would ask. We are doing an experiment right now. We have Udacity has its own car, as you know. And our goal is to crowdsource through competitions the various software components, starting actually next week, to be honest, before the curriculum even starts. So we already put one competition out for deep learning, where students can compete to predict what a human driver would do in response to a scene. That's a deep learning task. We're designing more in the area of localization, of control, and object tracking and predicting. All the essential things of self-driving car. The winners of the competition will make some money. They're going to be invited to Mountain View to hang out with me and other people here. And we hope, I want to show the world that we can actually crowdsource a self-driving car. I want to get this car good enough we can drive to San Francisco, just based on our students' work. And I want to do this really fast, because we have so amazing students and such strong students. It should be possible to go really fast.
That's great. Would that kind of beat even the Google challenge that you had with Larry?
Well, it took us 1.5 years to do the Google challenge.
Right.
We picked ourselves one of the little legs from the Google Challenge internally to drive, which starts here at Mountain View and goes to San Francisco on a surface street called El Camino Real. And if we can do this, then the next challenge will be to drive exactly the same routes that Google drove 5 years ago.
With crowdsourcing software.
Crowdsourcing, yes. And imagine this, if you as a student participate, right? Imagine you write the winning piece of software, right? And it's really amazing. And Mercedes comes along and says, we really would like that piece of software. And we say, yeah, we happen to know the girl who wrote it, right? Give her a call. She's in Australia. You can hire her. That's our goal. We do this really to promote our students. We don't do this because we want to build the 15th or 20th self-driving car company. We want to promote our students.
That would be an amazing world. Absolutely. Here's another question, very basic, but very interesting. I'm a front-end web developer. Can I use my background in the self-driving cars field?
You can, but I think there's a different skill set that you'll explore if you take on Nanodegree. Front-end is particular, I think, concerned with design, with speed, with a level of cleanliness, and it really goes into issues of user design, not just programming. And of course, we all know that the languages we use to program web browsers are not exactly modern. So you have to have a certain skill set to deal with various different kind of, in my opinion, broken languages. The thing that's different in the self-driving car field is that you deal with the real-world data. So you have like camera images coming in, and you have to write software that takes information from those images. It's almost the opposite of a web front end. In a web front end, you have information in your head. When you convey this to the user, here information comes in, and you have to extract something from it. And that process of extraction of information requires different technologies. So the machine learning is one, probabilistic techniques is another one. So I would invite you to join this Nanodegree and learn this different way of thinking, because no matter what you do afterwards, you have a much broader horizon.
With so many companies now looking to create their own self-driving car, are they basically using the same technology? One of our students asks.
There's a lot of overlap, and pretty much every company at some point stops by my office and gets the initial advice from me, so I know a lot what they do. One of the big shifts recently in the last few years has been the shift towards deep learning. You might all have heard about AlphaGo beating the world's best Go player. You've probably heard about our course on Udacity on deep learning that Google built with us. Deep learning is this crazy idea that if we just watch long enough and stare at something long enough, we eventually surpass human intelligence. And that's new. And that's really affected companies like NVIDIA, our partner, who's done seminal work, Comma.ai, Otto. They're now all shifting towards deep learning and away from more traditional techniques.
So it could be. This is one of our fun questions. With self-driving cars getting safer than human-driven cars, do you think eventually it'll be illegal to manually drive?
I hope so. I hope so. I mean, if anyone finds this offensive, then I really recommend you go to your local hospital in the trauma department and talk to the people who just came from an accident and might be dying. It is a privilege and pleasure to drive, don't get me wrong. But the way we do this, we lose more than 1 million people every year in traffic. And I think it's just unfair that we do this. We have something very lethal, something that can kill people. If a self-driving car becomes substantially safer, we should mandate the use of this technology, in my opinion. And there's precedent. If you are a pilot, I'm a pilot, and say you're a commercial pilot, and you fly, say, a 737, and you have to land the plane in bad weather, you are mandated to use the autopilot. You're not allowed to fly manual. If you fly above 18,000 feet, you are mandated to use the autopilot. You're not allowed to fly manual. And the reason is, statistics shows that human pilots have a much higher error rate than autopilots. And to save the lives of the people inside the plane, the FAA has decided to mandate the use of autopilots.
Do you think the U.S. will be the first country to do this, or will there be another country in the world that does it?
This is up in the air. I mean, the U.S. has its own set of challenges with its own regulations, and different states have different challenges. Obviously, right now, the U.S. is where the action is. I see more and more activity now in China, and certainly in Germany. Which country has the most friendly legal environment is unclear. So a good example is Singapore recently changed regulations and specifically invited self-driving taxis into Singapore as a solution for the last mile problem of trains. They might be the first.
Interesting. Here's a question from Kiran. I passionately visualize the future with all taxis being autonomously driven. In such a scenario, which entity would purchase the cars? Is it going to be companies like Uber or other taxi companies?
Yeah, that's a fantastic question. So generally, in a world where taxi fleets are self-driving, you still need taxi fleet management entities. And it could be Ubers or Googles, it could be independent companies that manage those fleets, or a mixture thereof. It could also be that people have cars their own and they join the fleet instead of parking the car when the car is not being used. One of those will succeed. And my most likely outcome will be that someone like Uber just buys lots and lots of cars.
Stefan has a question. How do you see the self-driving car technology in case of emergencies? Will we ever see self-driving ambulances or fire trucks?
Again, I hope so, that once this technology is superior. And maybe an ambulance and a fire truck are like 80% self-driving and 20% manual driving. It doesn't have to be 100%. But yeah, especially, I mean, if you look at emergency vehicles, it's a really complicated task to drive them well and drive them fast. And I would submit, if you were to work on this, that at some point we would be able to drive an emergency in a more skillful manner fast than most human drivers could.
Almost like a plane.
Yeah.
What are some of the learning models used in the self-driving car? For example, how is the LiDAR data used in determining position?
So these are two separate questions, and I'm going to ask the second one first. LiDAR data is basically produces a 3D point cloud around you. In the Google car, what we developed when I ran the team was a system to cache a map of the environment and then just do map matching. We would match the LiDAR scan into the map to get precision localization. That set of techniques is well understood and has become basically 100% reliable. It never fails. And it gives us very precision localization, so we can know with like 5 to 10 centimeter accuracy where the car is, which is very nice because if we want to stay in the lane, we can almost blindly stay in the lane at this point. Learning, all kinds of learning, from deep learning to parameter tuning. Back in the good Grand Challenge days, we had this ever-growing data file of terrain that had to be interpreted with lasers, where we had some ground truth data, and every time the rover did something bad, we would feed this bad data into our learning set and then overnight have it learn from it, and the next day we would take it out and it would be fixed. We have modes where the car learns from human drivers. Like for example, when it comes to speed control, humans have a specific way to drive, and cars can watch humans and kind of replicate the human driving behavior. That's phenomenally useful as four-way stop signs, right? And four-way stop signs is a US thing. We have all these, there's someone who makes stop signs that has like, I don't know, a link to Congress because we have so many stop signs. We have like millions of stop signs in every city. So they do it in 4 ways, and the rule is whoever comes first goes first. We programmed this in the beginning, and the car would wait until its turn, wait another 2 seconds just to be safe, and boom, somebody else ran him off. So if you just do what you're being told, you have no chance. You're never ever going to go. And the guy behind you gets crazy. So we ended up learning the communication language. So you actually inch with your car into the intersection in a specific way to stipulate now is your turn. And whoever inches the fastest asserts the highest priority. And you can try this out. I mean, try to just for the fun of it, go first even if it's not your turn, and just assert yourself and see how other people will respond. You see this entire language unfolding between these buddies that's moving, right? Sometimes even eye contact. So these are things we have to learn.
That's interesting. We have very little time left, so I need to ask you one quick question. Do you believe automotive companies will treat data as a competitive asset, or will they share it?
I suspect most companies are not into sharing. I suspect most companies will be building these silos. The only way you can see sharing is either that you have a monopolist provider that has something the others can't afford, like a good map data. And there, I would submit automotive companies are already sourced from companies like Navtech and others. Or you have the legislator step in and mandate a sharing layer, and that's typically very slow. There's a lot of work on car-to-car communication, where the idea is cars talk to each other. And the legislator has been trying to kind of build a system, and it's been unsuccessful so far in its release. But I could imagine that at some point, if penetration of self-driving cars is high enough, that there be some sort of normalized, maybe IEEE language for car interchange that would inform cars of each other and help them make it more safe.
That's interesting. Let me end this with asking you a personal question. You have one transformative industry called self-driving cars that you're considered the godfather of. You have another one with education and Udacity. What do you want your legacy to be?
Every time a Udacity student graduates and sends me an email and say, I found a new job or something like this, that's my legacy. I mean, I don't want a big legacy. I just feel there's so much good we can do in the world. right? I mean, all the people that in the future might not be in a traffic accident because of self-driving car technology, they never get to know me or whoever did this, but they still have an impact on the world. I just am so enthused to be in Silicon Valley and so intrigued to really think about how to make the world a better place. If I can even save one life or get one person in a great new job, that's worth it.
Thank you, Sebastian. It's been
Thank
amazing. Not even all the technology, just your ideas about the world. Thanks so much for joining us. See us next time on Series 7 of Udacity Talks. And in the meantime, go to Udacity and sign up for Sebastian's self-driving car Nanodegree program. Thank you.